So I would register the lecture today. Today is 3rd June. Finally, we're facing the year June. Maybe we're going to have rainy season in Japan. As usual, I have updated some files for lecture. Today, we're going to use these two files of 5.1 and 6.0. Yeah, just use this is your English directed lecture, and I just use English And also, I just accept English either. And I would say, do not hesitate to pronounce English. I would like to take attendance, so send me your student ID as your attendance via chat function. So as I told you, you need more than 80% of attendance. And then we're going to have, we means I myself and OPS is going to have some exercise or assignments or internal exam or something like that. And then if you get some points, more than 6%, finally you earn the credit of this lecture. The lecture schedule is, first half and second half by Open Sensei, something like that. Today, we are starting on 6th of May, June 3rd. Title is what? A lithium ion battery. From last week, we have started some battery science. So agenda today is what is lithium ion battery, but title is lithium ion battery, but we are going to see there some battery things, very much comprehensive battery things. And we're going to change the file, 5-1, last week one. I'm not 100% sure that here what is the last slide, last slide of last week, but I showed this slide, hybrid vehicle. You need battery, plug-in hybrid vehicle as well. And maybe I told last week that the fuel cell vehicle is not only fuel cell vehicle, but also this is a vehicle of hybrid car. And instead of intercombustion engine, you have fuel cells for driving a car. So the dams and nuke power factory and general power factory, in these cases, as I told, they're running just regularly, even at night, even in daytime. So that is very much economically quite advanced running. So at nighttime, people do not use a lot of electricity. Those time you need battery. Solar cell and wind as well. So it's very much up to weather, up to climate. So you need battery. Again, this is something a difference between Japan and English-speaking countries. Solar cell, maybe we call those solar battery. In this way, fuel cell, in Japanese, we call those fuel battery, battery called batteries. In battery science, you can categorize battery into two. First one is primary battery, and second one is secondary battery. Primary battery completely equals disposable battery. You can use at once, and after that, you just throw away those batteries. Use just one battery is, you may call that disposable battery or primary battery. And rechargeable battery, you can use a couple of times after charging. You may call that secondary battery. These two words are quite scientific words, primary and secondary batteries. Then we're going to see that those two batteries are some examples of those two batteries. The first one is very much typical primary battery, manganese battery. But English word, you may call those battery as carbon zinc battery. And alkaline battery is completely same manganese battery. This is the same, just the difference between these two are electrolyte is different. That's it. So this is a group of manganese battery or carbon zinc battery. In English, the other word is, you may call these batteries heavy duty. Heavy duty means it says quite reliable battery. So yeah, these are carbon zinc battery. The difference is this is cheaper. This is a bit expensive. So, but if you need high electric current, you have to choose this one, and low electric current, but constantly low and long period, you need those cases. You need just a manganese battery. And other primary batteries are silver oxide battery, lithium battery. This is not lithium-ion battery. This is a group of primary battery, lithium battery, or air zinc battery. Those are, again, disposable and used like you may call these coin battery or something like that. The shape is like it's coin. We're just going to look inside of the carbon zinc battery because this is quite typical battery. Carbon zinc battery, who invented this battery is a French guy, Leclanche, in 1866. And yeah, the tools inside is carbon dot here, and cathode is manganese oxide, and anode is zinc electrolyte, aqueous water, aqueous ammonium chloride. This is Leclanche itself. But who commercialized this battery is a Japanese guy commercialized this battery. The name dry cell battery, but completely same, which showing completely same composition. In 1878, this guy, Yai Sakizo, invented dry cell battery, commercial battery. But even now, we are keeping this composition as your carbon zinc battery. Nothing changes at all, almost same. So the general carbon zinc battery have aqueous ammonium chloride as electrolyte. On the other hand, alkaline battery has some aqueous potassium oxide electrolyte. Just differences. This one, it's also composition complete same, zinc, carbon wort, magnesium oxide, so electrolyte is different. And I told that to you. In example, 100 maybe you can purchase a battery in 100. These are a bit expensive, but the difference is just these use KOH instead. These use ammonium chloride, and electric current is different. So you have to choose not up to price, but up to electric current you need. Electrochemical reaction, this battery is something like this, and in anode, zinc melt into their ion to form these complex. And also in anode, you generate electricity, electron, and electron goes to from here, from anode to cathode, via external circuit, such as LED lamp, or electric motor, whatever, and finally it's alive in cathode, and in cathode, proton react with electron and generate hydrogen. But this hydrogen is captured in manganese oxide to give water. This is anode and cathode reaction. Oops. See, it shows that, but I really should. On the other hand, alkaline battery the reaction is almost same. Yeah, as I told, the just difference is electrolyte and base is contributed into the electrochemical reaction, and almost same story. Anode generate electron and it goes through the external circuit and finally arrived in cathode. Cathode reaction is, quite similar. The title today is what is lithium-ion battery, but you're looking at primary examples of primary and secondary batteries. By the way, we are very much, so we should be careful about battery voltage, because some battery voltage quite high and some low. And again, here you have to choose the battery voltage. But from the electrochemistry, how can you determine the battery voltage is as follows. A battery voltage, in other words, a battery potential is unambiguously defined with the merging of standard electrode potentials of electrode materials. So if you choose two electrode materials, such as some materials, anode and cathode, these are electrode materials. So if you determine that, that means at the same time you determine the battery voltage as well. Thus, the battery voltage is determined when anode and cathode material are determined. When you have chosen these two materials, at the same time, the potential of voltage of battery is determined at the same time. That is very much up to the difference of standard electrode potentials of these two materials. Of course, in some cases in electrochemistry, you are facing some issue of overpotential. So That's the voltage determined when anode and cathode materials are, excuse me, you need S here, are determined. However, the voltage shifts if the overpotential exists. But basically, if you choose two materials at the same time, you choose the battery voltage. This is for battery voltage. We are talking of primary and secondary batteries. And then now we are going to examples of secondary batteries. Yeah, as I talk a lot of time, lead acid battery, pronunciation is lead, not lead. Lead acid battery. It's the same as lead acid is obviously lead, Pb, and sulfuric acid is acid, but general name is lead acid battery. Nickel cadmium battery we don't touch because composition is almost same, and these days you don't see the nickel cadmium battery because the toxicity of cadmium. Now we are using the nickel metal hydride battery. It's quite common. NAS battery we're going to see, and lithium ion battery as a title. This is appearance of the lead acid battery. Yeah, again, I think you have ever seen this battery before because in your car you have this type of battery, or your motorbike. Your motorbike has this type of battery as well. Yeah, it's on several types, several size of the battery, but appearance is almost same. Sometimes people call this acid lead battery, that's the same. We're going to the electrochemistry of the lead acid batteries. Anode minus electrode lead to melt into the electrolyte to form the lead diode. Finally forms lead sulfonate. In cathode material is lead oxide and react with proton and sulfuric ion and electron. Yeah, of course, this electron coming from anode via external circuit, and then finally forms these two materials. This direction is charging, excuse me, discharging, this direction is charging. So that means this is equilibrium. That means these are second rechargeable batteries. I think, yeah, you have ever seen this battery as well. Yeah, it says rechargeable nickel metal hydride battery. The brand name is Eneloop. This is originally from Sanyo, but Sanyo and Panasonic fused at present. I think present Panasonic has two brand name for nickel metal hydride batteries, Eneloop, and I forgot the name from them, originally from Panasonic, but to battery. But these are well-known name, I think, nickel metal hydride battery. Yeah, name is here. Then we're going to see the electrochemical reaction. MH means M is metal, and MH means metal hydride. This is metal hydride. Go mix these two lines and then draw metal hydride. Metal hydride means metal, such as this case, quite complicated metal. This case, alloy metal and hydride. H minus, hydride is H minus. It's directly connected. Hydride means hydride equals H minus. And in cathode, we have nickel oxide react with water, and from electron is always coming from anode via external circuit. And finally, you get a nickel oxide and OH minus. And this M is quite complicated, and it calls intermetallic compound or hydrogen absorbing alloy. Alloy is like 2 or 3 metal fused into one material. That's an alloy, in this case, alloy. So they are coming from 2 elements, 2 metals, and A equals lanthanum, cellium, neodymium, or I forgot the name, excuse me, B equals nickel, cobalt, manganese, and yeah, something. These alloys, that's a hydrogen absorbing alloy. So it's and this is a reaction, and again this equilibrium reaction. So that means you can use this battery as for a couple of times. By the way, again, first, by the way, today is battery voltage, and second, by the way, is what is the indexes of the dimension and weight in batteries. So we need small and light batteries, I think. We need example. This lead acid battery is quite heavy. Maybe if you have experienced the replacement of this battery, it's quite heavy. So yeah, this is not so bad. But always, a humankind needs a small and light battery. We are always seeking small and light batteries. So you need some indexes to describe lightness and smallness, let's say weight and dimension indexes. They are indicated with indexes or energy densities. We call that those indexes, energy densities. So in fact, there's many indexes like energy densities or power densities, also indexes of batteries. But today we're going to talk of, I am going to talk of only energy densities. The equation of energy density is as follows, like quite simple. Battery voltage, I have already told about battery voltage, how you can determine battery voltage. Battery voltage times only capacity. Capacity is dimension or weight. Dimension or weight. That's it. So there are the two energy densities over weight over dimension. So this is called, you can call that, this is how light is the battery. So how small the battery, how small is it? These are indexes of batteries. So you need very much high number of these indexes. So that means specific dimension, how much energy you can store in this dimension, or per weight, quite how much energy you can store in this weight or something like that. You need both number, quite higher, but it's quite hard story, and you can lies one of those, but you can just keep one or something like that. So it's all again up to the how you can use your battery. Like in the case of vehicle, this is much more crucial. This is when you design a vehicle, example, Toyota produces the Prius. Prius designing is following that example. Prius has some storage. You need some storage. 3 golf packs is finally stored in the storage with them. 3 passengers. So 3 guys are going to golf with their luggage, something like that. So in the case of vehicle, rather weight, but the dimension is quite critical. So for vehicles, smaller battery required rather than light battery. So these are energy densities for weight, for dimension. This is kind of example, and this is nickel metal hydride batteries. The voltage is average voltage 1.26 or something, and you might think you have like double voltage. Just you can have some direct series connection, and finally you can get double potential of the battery. But at the same time, your battery becomes weight double or volume double. So that means if you're going to use a lot of batteries, energy density is exact same. So energy density is something battery. A single cell has a high voltage, or a single cell has high capacity. Those are required. we don't see at the lithium-ion battery, just read comparison, those voltage. Lead-acid battery has a voltage of 2.0. Nickel metal hydride battery has 1.26. And lithium-ion battery, example, in your pocket you have your cell phone, or you're watching this lecture with your PC, and PC and smartphone has some lithium-ion battery. Voltage is always 3.7 or 3.6 because cathode and anode material is almost same. So only the maybe you can roughly tell that this is smallest and lightest battery among these three. And roughly, just only this is only from the result of the voltage, but roughly you can tell that this battery is lighter and smaller. Oh, we have done this exercise already, right? So here, we just switch the story of today. Files, repelled, share, schedule, I told. And we are standing on here, and next week is final lecture of mine. And after next, Okuya Sensei going to showing up here. Agenda today is we are doing what is lithium-ion battery. All right. Exercise 1. Right. We have 2 exercises today, and exercise 2 is exact same as last week exercise 2. So just you write the answer of exercise 1 and send me via email. Exercise 1, physical properties of the materials and system can often be categorized as being either A or B, according to how the property changes when the size or extent of the system changes. A quantity is one whose magnitude is independent of the size of the system, whereas B quantity is one whose magnitude is additive for subsystems. This reflects the corresponding mathematical idea of mean and measure, respectively. You may also call them as A and B variables. What are A and B? Furthermore, illustrated by examples, respectively. This is exercise 1. Deadline the same as last week. So, yeah, we're going to see again. Exercise 1, physical properties of material. So the A and B it's something like showing in science, and B showing some quantities, a group quantities. A and B, independent. They are independent, completely independent. A and B. I think there is no group overlap here. I don't think there are group overlap. Overlap means these are group overlap. Groups overlap is like this. But I think there's no overlap between A and B. So in science, group A variables, group B variables, and let's say those are maybe you call that an A unit or B unit. A variable or and B variable or A and B have own units. Yeah, we have already seen some units such as a degree centigrade or liter or degrees Fahrenheit or something like that. So A is completely different, independent from B, I think. B is completely independent from A. There are the two variables in science, and A group has independent units and B group has independent units. And I do not think A and B has some group overlap here. So what is A variable? What is B variable? That is exercise 1. And we're going back this exercise 1 at the end of this lecture again. And also, I'm going to show you exercise 2, but exercise 2 is exact same as exercise 2 last week. So make sure just exercise 1 via email to my email address. You have to give your student number and the mail title. You should also start with student number, student ID, and your name in the main text. And attached file will not be accepted. So hopefully, just you write down inside of the main text. The deadline is by June 3rd, today, 12:45. Yeah, today's agenda, today's lecture title is 5M lithium-ion battery. Yeah, we have done with some energy densities. So at present, we need high energy densities or long-lived. So long lifetime battery you need. And that's, oops, excuse me. Long-lived battery you need. So long lifetime equals long lifetime means like you can use your battery for 1 year or 2 years or something like that. And the other long lifetime means once you charge, how many hours you need, you can use your battery or not is, which includes the energy density includes those properties. So this is charged lifetime, or this is real lifetime of the battery. And after present secondary batteries, research are now going to looking at magnesium ion battery, because the magnesium has 2 electrons, but lithium has 1. So they are, let's say, multivalent metal. You need some multivalent metal. Polyvalent. Polyvalent metal battery. Yeah, present research is going to not single valent metal such as lithium battery and magnesium 2 electrons, and zinc 2, or aluminum 3. You can get 3 one oxidation. So polyvalent metal battery is kind of the target at present research. Yeah, aluminum is not only the 3 electrons, but also price quite cheap compared with lithium, magnesium. I never comparison with zinc and aluminum. Aluminum is inside town. You can see a lot of aluminum cans. So the aluminum is kind of target, but it's quite tough research project to use metal aluminum battery. And maybe air metal battery is one of the target of the present research. How come air is like, this is air metal, but in fact, people use not air, but oxygen in the air. So correctly, oxygen metal batteries must be the correct name in air metal battery. Generally, you have your battery. Inside the battery, you have cathode materials and anode materials and electrolyte. So it's quite heavy. But air metal battery cases, oxygen is cathode. So oxygen is like sometimes visit when during the charge your battery, I guess oxygen is used, and when you use your battery, discharge oxygen absorbs. So the oxygen is kind of equilibrium. So the weight of oxygen is just almost free because outside of the battery, oxygen comes, and from the inside of the battery, the oxygen goes out. So now the weight of the battery is quite light. There's no cathode weight in your battery. So for light battery, air metal battery, oxygen metal battery is one of the target in the present research. The next one, organic batteries. The present battery is cathode is cobalt or sometimes manganese or something like that. Not so expensive, but not so cheap metal you have to use. But if you see it's organic, everything is quite cheap, and you can produce compound from just carbon, oxygen, and nitrogen, CON or something like that. So it's quite cheap battery, and if you imagine like metal and organic compounds, this sounds quite light. So organic battery is kind of target. Organic accent here. Organic. Japanese accent is top, so organic or something like that. It's correct. It is not correct. Organic is correct accent. Inorganic is same. So fourth one is all solid state battery. Present battery is cathode anode solid state, but electrolyte is liquid. So leakage always happened, and present electrolyte is organic molecules. So once the bigger traffic accident happened, maybe it burns, especially voltage. Yeah. This is battery. This is battery. And high energy. High energy state is full charge battery. It's high energy. If I'm going to take the lithium-ion battery examples, so many lithium ions just go out from the cathode and get into the anode. Those full charged state is high energy, and once vehicles crashed with full charged vehicle crashed, I think it's accident, maybe I'm not sure yet. So you get some big accident, fire, and others. So one of the trigger is to prevent the leakage of the organic electrolyte or solid state battery is kind of research term. Yeah. So finally, we're going to see the lithium-ion battery. This is from the a couple of years ago. I have a lecture in Toyama University, and my my lecture here is just some basic lecture of the rechargeable battery, especially lithium-ion battery. So this is the abstract of that lecture in Toyama University. Urgent requirements for the rechargeable battery, such as the lithium-ion battery, are that to be small, light, long-lived. Yeah, I have already told. We just need small, light, and long-lived batteries. People would accept a smartphone for over a week and an electric vehicle passing the cruising distance over 500 kilometers in one charging. So I think in your cases, once a day you have to charge your smartphone at present. No, my case very much yes, especially if I use like telework. I think you are facing the same issue, like a discussion via Zoom or Skype or something like that. Yeah, you need a lot of electricity. So if on the tap, it doesn't matter. But if just you use your battery, it's battery quickly gone. So you need some only weekly charging, or from the one charging, you can cruise, you can trip 500 kilometers or something like that. This weekly you need. Yeah, indexes I have already shown, and you need some long life battery. I do not talk about some solution of long lifetime, but first we're going to see the composition of lithium-ion battery. Yeah, maybe bigger. Beyond that, why lithium is, we're going to see the standard electrolyte potential of the elementary substance. Elementary substance means just element. This is not compound. This is not compound. This is not equal compound. This is not a compound. That means maybe you can invent a novel compound which has very low standard electric potential or very high standard electric potential. So you going to choose those two materials, maybe you can have very much novel materials, novel materials, and you compose some novelly invented materials, and maybe you can have battery which has very high voltage. At present, the lowest standard electric potential is shown by lithium as an elementary substance. So, lithium on the other hand, fluorine, I do not wrote the fluorine here. Fluorine has the highest standard electric potential as elementary substance. So at present, if we use just the elementary substance materials, these two combination gives you the highest voltage of the battery, but fluorine is highly toxic, and I guess this voltage is like a 6 volt or something like that. So they are quite smaller, but smaller battery can produce from the lithium and fluorine. Yeah, fluorine is quite toxic. So if you can synthesize some novel compound which has, like quite low, quite high standard electric potentials, so maybe you can have novel batteries possessing quite high voltage. That means very small and very light. But present, the element is lithium, the lowest, -3.045. That reason we use lithium. Yeah, standard electric potential is quite low, and atomic weight is almost 7, and density is 0.534. So that means quite light and quite low. Thus, lithium is quite light, but possesses dense power. So quite light, but the potential is low. So lithium have quite dense power. That's the reason lithium is at present, we are taking lithium. So this is composition of lithium battery. Cathode is cobalt oxide. Generally, there's many compounds at present you can use, like example, manganese oxide, or quite cheap one is P4. Yes. Yeah, this number is not so sure, so maybe this is wrong. I'm going to correct next week that these material is adopted as cathode materials, and name is lithium-ion battery, and I'm talking of lithium is light. Lithium has dense power. But you might think anode must be lithium, but this is not lithium. Anode material is not lithium metal. People want to use a lithium metal because, yeah, as I told you, quite energy is dense, but really, really reactive lithium metal is. Even now, people are doing some research to use some lithium metal as anode. safely, but not succeeded yet. I guess last 30 years, Japanese industrial ministry and also NEDO is going to try to produce some lithium metal battery, but never succeeded yet. Instead, you use some carbon material. Carbon. I draw the layer structure here, but this is graphite structure, and these layered structure lithium plus comes into these layers, and near here, you have electron in the church. Near here, you have electron. They say that this pair is not lithium metal. This is lithium, still lithium plus, and near here, electron minus is here, and the ratio of carbon and lithium plus is 6. One lithium ion and one electron. This means almost one benzene. Graphite has made from graphene. These are one graphene, and graphene is a piper of the conjugated benzene. So one benzene could accept one lithium plus, and which locate around here, and near here, near reaction to form lithium metal, but near here, electron exists. They say that. I'm not sure. I've never seen the lithium plus inside of the graphite yet. So the ratio is 6 to 1 to 1. So around here, at the middle, at the center of the benzene ring, you have lithium plus, and around that electron is. That is a charged form of the graphite. You have cathode, cobalt oxide, something like these compounds, and anode is graphite. And cobalt oxide also layered structure. Now, this is not layered. This is spin out. So the crystal structure is different, but layered. So almost a lot of lithium process migrate from here to there. That's quite dense energy state, quite dangerous. If I draw, it's quite simple, but in fact, battery inside is quite complicated. This is cathode, this is anode. So the position is switched from between right and left from the previous. This is minus plus, but at present this is minus plus, and inside electrodes a lot of some complicated stuff exists, like just graphite you have here. That not only graphite, but you need some electron conductivity. So current correct copper. You need a copper foil here and graphite. And binder, if only graphite, it's fall down, and so you have to immobilize graphite. To do that, you need some adhead. So you need binder. Generally, you use some polymer, PVDF, fluorine polymer. This is some you need. Also, electron conducting auxiliary you need here to form the anode. And this is electrolyte, and cathode is almost same story. Not only the cathode materials, cobalt oxide, you need some binder to immobilize this stuff, and also to get the smooth electron conductivity, conducting accessory you need. And finally, you're going to correct the electron at the aluminum coil here. This size aluminum coil and this size copper. So quite composite and quite complicated structure those electrodes have. If I illustrate, it's something like that. This is from the same image. This is the illustration. So both electrodes. Active material means really redox material, real electrode material. So in the case of lithium battery, graphite and cobalt oxide, active materials. This is active materials, and around active materials, the binder, you have coating of the binder, and you just bind each other's electron conduction auxiliary need to electron conduction from here to current collector, aluminum or copper. So quite composite, complicated structure. It's all solid state, and liquid electrolyte is coming into this way. And to complete the not electron conduction, but ion conduction, lithium conduction. So when you charge your battery, so the electron, you give electron from this side, from the external circuit, and electrolyte, in electrolyte, lithium price goes from right to left, from cathode to anode. I am now talking of charging your battery. So when you charge, the chemical reaction is something like this. The cathode, cobalt 3 becomes cobalt 4, and balance control, the cobalt 3 becomes cobalt 2 by oxidation. Just remove the electron here. That means oxidation. And lithium plus migrate to there. And yeah, as I told, one benzene unit gets one lithium plus electron to form this compound, but never lithium metal, lithium 0, still lithium 1 plus here. This is a discharge. No, excuse me, this is charge. This is charging the battery. And discharge is completely vice versa. And lithium platinum is going from left to right. And that's at the same time, electron goes from left to right via external circuit, and lithium plus meets an electron again here, and to control the valence, the reduction of cobalt 4 to take a place to give finally cobalt 3 again. This is discharge when you use your battery. So discharge, and this cycle is charge and discharge. This is a story is only cobalt oxide. In the case of cobalt oxide, you cannot use all lithium plus in a cobalt oxide. Maximum is 50%. And 50% cobalt you can use. Because these cobalt lithium products are not only just staying here, but also those are function as a column of the these layer structure. Or if you use almost all lithium products from completely, you get some empty cobalt oxide here, and the layer structure is collapsed. Never you can get this layered structure again. So no more equilibrium. So just you can use 50%, and you can leave some lithium products here as a columns and keep this structure. And then the reaction is equilibrium. So you're just wasting almost 50% of the lithium. If you can use that, quite a rough calculation, you can get some half size of the battery, even if you can use all cobalt or lithium ion in the cathode material. And these are story of charge and discharge of lithium battery, and in fact, these are our research. My research in Shizuoka University, our project is a modification of electrolyte. Electrolyte is just a mediator of between cathode and anode, but you need some specific property for the electrolyte as well, not only for electrons. Electrolyte is a mediator of the lithium plus. So this case, this as a lithium salt, generally you use the lithium PF6. This is quite cheap, and this is you can form lithium plus and PF6 mines quite easily. That's the reason. Most cases you use a lithium PF6. And as a solvent, organic solvent, you use ethylene carbonate and linear carbonate as well. Cyclic and linear carbonate, these combinations, these are two, again, quite cheap. And why carbonate is? This is coordination chemistry. So for molecules surrounding this lithium plus, and then these guys are bring lithium plus from right to left, or vice versa. So this coordination chemistry is critical. So you need some coordination site here. So just hexene or those solvent, you cannot use those solvent. You need some site of the coordination. So the you have to correctly choose these solvent and electrolyte salt as well. Electrolyte is consists of electrolyte solvent and electrolyte salt. Yeah, this is a story of the electrolyte. So once I just skip this part, because quite, like specific story. So just one, I skip. Just skip. By the way, third by the way today. First by the way is battery voltage. Second by the way is indexes of batteries. And third by the way, the final by the way today is word, a definition of word anode and cathode. Yeah, we're going to define the word cathode and anode. Cathode is the electrode accepting electrons from the external circuit. Yeah, you agree. If you see the lithium battery, the picture of the lithium battery, always accepting the electron from the external circuit. And where the reduction reaction takes place. This is definition of the cathode. And in this way, anode is the electrode emitting electrons through the external circuit where the oxidation reaction takes place. Yeah, you remember the drawing of the lithium ion battery, and the anode and cathode definition is something like that. However, the situation of the rechargeable battery is quite complicated. Yeah, if you see here, the drawing of the battery, again, yeah, this one. And cathode and anode. Anode definition is, cathode definition is oxidation reaction takes place. Yeah, oxidation, lithium 0 to lithium 1, and cobalt 3 to cobalt 4. Oxidation reaction takes place, and always this is charging. Yeah, this maybe this charging is better. Yeah, discharging is cathode is accepting electron, anode is emitting electron. So that definition I have told is when you use, in case of discharge, it's correct. But rechargeable battery cases is not only discharging, but also charging. Case of charging, story completely different. Not always anode is always not emitting electrons, but this case of charging, so you are accepting electrons. So definition of cathode and anode is in the only case of discharge battery is quite complicated. The basic definition of cathode and anode is these are correct electrode accepting electrons from the external circuit, accepting electrons. So yeah, this is when you use your battery. So discharging. This is also discharging. Anode is electron emitting electrons when you're discharging. But case of charging the battery, the direction of electron is completely different. So that means that reason. However, the situation of a rechargeable battery is quite complicated because when you discharge, this is correct, but when you charge, this is incorrect. So cathode and anode definition is, in the case of rechargeable battery, their definition is quite wider because the other side exists. Other side is correct. But the general definition is correct. And if you see here, like diodes, LED, whatever, LED is It's same cathode is anode is yeah. It just follow the definition of the I have told. So only exception is when you recharge your battery. That's an exception of the definition of the anode and cathode. Yeah, we have done 3 by the ways in today's agenda or title of the lecture is what is lithium-ion battery. Well, we have done the lithium battery. Maybe the other well-known present rechargeable battery is NAS battery. Generally, NAS is quite huge battery. This is some appearance of the factory, and outside of the buildings, you have NAS battery in this case in something like this. So huge storage, case of huge storage for like electron shutdown. Once electron shutdown happened, you should stop all of the function of the factory. That it's you know, it is a lot of cost to complete shutdown. So to maintain those electricity, you need sometimes huge battery system. NAS is very much good for them because quite safe. NAS N is sodium, Na, and NAS S from sulfur, S. So the anode is sodium and cathode is sulfur. And the electrolyte and beta alumina start the electron conduction at around 3 or 350 degrees centigrade. So they are almost cases at room temperature. This is completely shut down. No electron conduction between cathode and anode. So no short. And so that means these are quite safe and very much good for these big storage of the factories. Maybe not for cars. These are not so, yeah, energy density is not so bad, but maybe obvious issue is sulfur. Once sulfur, exposed to the air, the smell is like woof. You cannot imagine the smell of sulfur. Like maybe you can use gas every day from the gas pipe or something, and gas is no smell and no taste. So for emergency, the gas company puts some smell to the gas, and that means gas smell is, maybe you can find out the gas leakage from the smell. But in fact, gas is no taste and no smell. And gas smell is, it's kind of sulfur smell. So the structure is like alcohol is like ethanol. So here, its general structure is like herb, which is alcohol. Instead, sulfur smell is coming from not O but S. You may call this thiol because this is alcohol. Sulfur alcohol is thiol. This one is quite smell either. And this sulfur is smell even if after reaction, something like that. So smell is too bad. So maybe not for a car. Yeah, present research is going on with them, like lithium sulfur battery or something like that. But always have some program for the sulfur smell. But the present NAS battery is quite a good battery for the big storage. Right? Maybe almost time is coming, so exercise 1, I told on exercise 1 answer you send me, physical properties of materials in the system can often be categorized as being either A or B, according to how the property changes when the size or extent of the system changes. A quantity is one whose magnitude is independent of the size of the system, whereas B quantity is one whose magnitude is additive for subsystems. This reflects the corresponding trial ideas of the mean and measure, respectively. Yeah, I told. You may also call them as A variable or B variable. Oh, in the period here. I'm sorry. In the period here. Then the question is, what are A and B? Furthermore, illustrate by examples respectively. Show me the example of A and B. Exercise 2, it's same exercise 2 as last week, and next week, as an internal exam, I'm going to ask the answer of the examination 2, exercise 2. What is exercise 2 is? Who is your supervisor? What is your research project title, and abstract your research project? These three. Who is your supervisor? Second, what is the title of your research project in master course? And third, abstract your research project. In abstract, you cannot use some, very much complicated acronyms or complicated words, at least which I could understand, right? Exercise 2 consists of 3. And first, who is your supervisor? Second, what is your project title, research project title? Third, abstract your research project. These 3. I'm going to ask next week these 3 and make sure that if those are not sure, ask your supervisor and abstract yourself. But you have to send me the exercise 1, answer of the exercise 1 until 12:45. Right, is that it? So the next week is final lecture of mine. It says examination, but some battery things left. So not really examination, but we're going to have some exercise, and one of the exercises is exercise 2, I told, and as a stuff of the battery. Okay, see you next week.